This is Math 30-1, and in this chapter, chapter 2 of our course, we are looking at radical and rational functions. The first section, we looked at radical functions, where we do the square root of a function, and we explored what the graph would look like. Now we switch to rational functions, and in this section, 2.3 and then 2.4, that will be our focus. So as you look here, you will see a number of measures of success. Let me walk through these with you. And then some of them may not make sense just yet, but we'll just talk about them as we get started. So, to begin with, if we're given an equation or a graph, we want to be able to explain why it is or is not a rational function. So, we want to be able to recognize rational functions from their equations and also from their graphs. Graphs sometimes are tricky, but we'll see why as we get into today's lesson. Next, if we're given the equation of a rational function, we want to be able to determine equations of asymptotes. So in grade 11, you looked at asymptotes, and we'll talk about those a little bit more in this lesson. We also want to determine coordinates of points of discontinuity. That's something completely new. Those are tiny holes in the graph. Next, we want to be able to determine x and y intercepts. Those are familiar, we've done that before. And then state the domain and range of the function. Remember, domain is possible x values where the function is defined, and the range gives us the y values where the function is defined. Next bullet, given an equation, we want to be able to sketch the graph of a rational function. And really, 2.4 just takes that a little bit further and gives us a slightly more comprehensive procedure. So if we get this lesson down well, 2.4 will be no problem. Finally, once again, we're going to look at equations and solving by graphing. So in grade 11, you solved rational equations algebraically. This year, all that we're required to be able to do is solve by graphing, which makes the process a little bit easier for us. Well, as you look at the rest of this page, you will see that we have a warm-up question here. And then if you were to flip to the next page, there's another warm-up question. I would like you to pause the video at this point and complete the two warm-up questions. Beneath each grid, you'll see some statements. The function is blank when x equals 2. Don't worry about filling in those blanks. You may have an idea what goes in, and if you do, that's great, fill it in. Otherwise, just let it go, and when I go over the questions with you, then we'll get those blanks filled in. So at this point, you can pause the video. Oh, maybe I should just talk briefly. So here, for question number 1, we're given a set of x values, we're given an equation. We want to determine the y values and then plot those points on the grid we're given, and then do our best to sketch what it looks like the curve would look like given those points. Okay, so I'd encourage you to do this without a calculator. You can compare the graph with your calculator after you've done it by hand. Okay, it'll be the same idea for question number 2. All right, so now you can pause the video and restart once you've finished these two questions. Well, here you can see my table and my points plotted for the first graph. And so as you look here, you see that towards the ends, my y values are close to a y value of 1. At the left end, I'm at 5/6, a little bit less than 1. At the right end, I'm at 5/4, a little bit bigger than 1. And then as we get close to an x value of 2, we see our graph going up on the right side and down on the left side. So actually, we're going to have some asymptotes here. So I'm going to draw in these asymptotes. And when we draw asymptotes, we draw them as dotted lines because they're not actually part of the function. And I'm trying with a ruler here. We'll see if this will work. Not too bad. So I'd say that would be a vertical asymptote where my x values are equal to 2. And here I'll have not working quite so well, going a little bit low. Well, more or less, there's a horizontal asymptote where the y is equal to 1. So here we have y equals 1, and here we have x equals 2. Now, so far I just drew dots, but I should connect those dots. Well, there we have it. I didn't quite hit every dot as closely as I would like to. It's a little bit tricky on this screen. Hopefully on a piece of paper you can be a little more precise. But there's what I'm getting from my graph for this rational function. So we would say that when x is equal to 2, well, we said that the graph has a vertical asymptote. So we would say that the function is undefined when x is equal to 2. And that's how we'd fill in those two blanks. Let's look at the next page. Well, here you can see my y values, and you can see the points as I plotted them, and more or less, it looks like they're forming a straight line, except there's something a little bit odd about this line. Now, as we look back at our equation here, we have this x minus 2 in the denominator. And we know that whenever we have a fraction or a rational expression, we can never divide by 0. So x minus 2 cannot equal 0. So that's going to be a restriction on this function, which means that my x value cannot equal a positive 2. So for this function, where x is 2, we're going to have a hole in the graph. So I'm going to draw it with an open circle here, where x is 2, and where the y value, it looks like it would be 4. And other than that, it looks like it's a line. So again, I'll see what I can do with my ruler on the screen here to draw the line. Oh, the ruler's not spectacular, but connecting those points. And we want to make sure we get all those points connected, but we do have that little open circle at that ordered pair, which is 2 comma 4. And so once again, we're saying that our function is undefined when x is equal to 2. But we'd say the graph has a point of discontinuity where x equals 2. And a shorter way to say that is just to say it has a hole. So there's a hole in the graph at that point. Well, we're going to explore both of these types of graphs as we look at a variety of different rational functions, continuing on in this lesson. So first of all, let's define a rational function. So a rational function has the form f of x over g of x, where f of x and g of x are both polynomial functions, and with that restriction that the g of x function cannot equal 0. We also say that the graph has a non-permissible value